In this video, we're going to be talking about supply grill auto-sizing. So this is the first video in our auto-sizing series for these air terminals. They all function very similar, but I'll try to walk you guys through each one with videos building upon the previous. So I'd encourage you to start with this video here before watching the linear slot auto-sizing diffuser because they all get more complicated as you go on. But not anything that you guys can't understand. So we're going to look at supply grill auto-sizing. In the user manual, we talk about this constraints group. We've spent a lot of time detailing exactly where these parameters are sorted and even the sequence of them so that you guys, the users, get the same experience from family to family. This essentially is the command center or the control center, whatever you want to call it. These parameters are how you can control the entire family for visibility wise and graphic wise, and then the details fall in the other categories down here depending upon what you want to find out. So these auto-sizing families, they require design parameters. So for the supply grill, essentially we're using design core velocity to auto-size the family. I have some additional, so anything grayed in is formula based, which means you can't edit it. So the 6" by 6", which is the values that show up in the schedules and tags right here, you can't edit because that's where the formula resides. So this builds upon a system of calculated final values and overrides. So in this case, anything with an input is an override in that sense. We've included sizing instructions for you guys. So for every type of family, you can hover over the sizing instructions and see what your valid inputs should be. So in this case, available sizes 6x4 through 48x48. These are based upon Titus air terminals, so I can't speak if these will work for other manufacturers, but there's no reason other manufacturers couldn't have families like these. And then lay-in sizing instructions, essentially available in all standard module sizes with neck sizes up to module size -2 inch. So essentially what that means is if you choose a 24x10, you can only go up to a 22x10 duct connection. So yeah, I guess let's start with that. All right, so I'm going to scroll down to, I guess another parameter before we get started is this message center. This has been already discussed in many locations in the user manual, and these families are no different. This parameter is here for the users to guide them through some of the calculations and some of the auto-sizing functionality and host family functionality so that you can truly get through this with valid information. All right, we have our performance data, which is only available because we've created performance tables as CSV files from Titus's catalogs, and I'll open one of those up for you guys. And then we have down in data, so airflow is the entered airflow, and then pressures that are found in the performance table. And then down in data, essentially what I'm giving you guys for validation purposes is the inputs that I've used in the performance table to find my values. So we've spot checked a lot of conditions, but when I say a lot, we've checked 100 or less conditions. However, there's maybe 5,000 conditions in the performance table. So I would encourage you guys as you start using this to check these values, and it'd be doing me a huge favor to continue to check and find conditions that aren't fully addressed yet. Hopefully there's very few of those or none, but I think it would be overzealous of me to assume that there's no errors with how much data that we've put into these. So the performance data URL right here This is here for every family so that you, the user, can click right on it and go right to the performance table and verify your numbers. So we'll actually be doing that on this family in just a moment. And then we have some, and then we talked about the custom selection type parameter. This is to override anything that's selected in the host family. So this is when you have a very unique, situation for a diffuser family, and it's just going to be used once and then you're done. You could use this parameter to override it, and you could basically make this into any family that you want that's nested in the master family. So like right here, I could choose this drum louver diffuser, and I could use that. But this is just an override for unique situations. All right, so let's go through some autosizing. So these design core velocities you guys can update. I've picked initial values to try to keep most NC values under 30, but that changes, as grills get very, very large. So, I've tried to hit most cases. So let's give this diffuser some airflow. Let's give it 1200 CFM. All right, so we have found through autosizing that this wants to be a 24 by 12 inch grill. The NC value is this value right here, which is detailed on the title sheet. That right now is an NC of 30, and here are our throw properties. Some families have vertical and horizontal throw properties. These ones, I don't recall if they were different. They were not different. So I didn't have that available from Titus. But also, if you look down in throw distance instructions, you can edit the blade double deflection angle to be 0, 22.5, or 45 for the correct throw data. So that's probably down in dimensions. So you could edit this to get to a very specific selection. So let's put that at 22.5. And as you can see, the throw values have updated accordingly. All right, so I'm going to put that back at 0. And let's go and look at what the family is actually doing. So we're going to this design core velocity in the performance criteria, and we're looking for 1200 CFM. All right, so here's that table. This is a URL right to Titus's website. So hopefully, if they update this, they'll be able to maintain the same path so the families can maintain the functionality. But on any note, we're going down this 700 feet per minute core velocity. See right there, core velocity, until we find 1200. So we're scrolling down, and now right here we got to 1200. So 1274. And now the family said it wanted to be a 24 by 12. So what we did is we chose all the bold sizes in this performance table for default conditions to start with. So now that we've found a valid size, these are the values that I'm returning. So that 0 degree was right here, 36, 46, 66. Let's go and take a look. So right there, 36, 46, 66. So we just validated another data point out of the 5,000. Now, the nice part about this is we're able to return the duct area, which now we can use to size other dimensions of the family based upon this. So for example, if a user said they had a specific situation and they want the height of this to be 16 inches. You can choose to override one of width or height, and then the other size will be auto-sized. So in this case, duct width now is being auto-sized, and that is now 18 inches. Now let's say you wanted 8 inches. Just the same, duct width is sizing to 36 inches. So as long as you guys, maintain the rules in these surface mount sizing instructions, you'll have fewer errors. We couldn't control every value that a user may put in here. So say, for example, someone put in 3 inches. The family is saying it's a 96 inch by 4 inch, but that's not realistic, and that's not going to be available from the manufacturer. So it's just important to follow the available sizing instructions. And then if you override 2 dimensions, then you are, so let's put this at 10 inch. And now we've got a 30 inch auto size. If you want to lock that size in, all you have to do is change both the inputs. So now auto sizing enabled, turned off, and now the family has gone into the mode of finding your performance information based upon your inputs. So right now we're at 38, 49, 70. Let's say so now we're going to override multiple dimensions. So let's go down to a 24 inch. So as you can see, as you would expect, the NC value has increased, throw values have increased. So now we're looking in the performance table based upon this duct area, essentially, instead of the core velocity. That essentially is the first auto sizing family. All of your throw data is right here, and NC values, it's under mechanical, and it'll just take some getting used to the fact that you can't edit this duct size, here. You have to go to the input. This actually makes you think you can edit it, but well, that's not supposed to work. So don't do that. Don't edit these values here. Go to the input and edit them that way. So as you guys use these, continue to check values, and let us know if there's a unique condition that you don't think is right, and we can update the formulas. Thank you.